Hi everyone, and welcome back to another video. Today we're going to look at the relationship between skull shape and size and hair loss. So here we have a research paper that says the skull often appears larger and more bulbous in shape for those who experience severe androgenic alopecia or pattern baldness relative to those who do not. We also have some anecdotal data from comments like this one on Reddit that say, yeah, I have a light bulb of a head and it makes things 10 times worse. So is there actually any validity to these claims, and is there any science to actually back these claims up? So that's what we're going to look at in this video. First of all, let's just quickly recap conventional wisdom in the hair loss space, and that is that testosterone gets converted into its more androgenic form, dihydrotestosterone, or DHT, by the 5-alpha reductase enzyme. And you might sometimes hear that testosterone is reduced into DHT, and that's because the double bond between carbon 4 and carbon 5 is actually reduced into a single bond. And we can see this happening inside of hair follicle cells, where testosterone diffuses through the cell membrane, gets converted into DHT, it binds to the androgen receptor, and this leads to a whole cascade of biological events that over a number of successive hair growth cycles leads to hair thinning or hair follicle miniaturization. And that's because signaling proteins like DKK1 or transforming growth factor beta 1 are strongly associated with the laydown of fibrotic tissue, calcification. It impacts the WNT pathway, and so on and so forth. And this can happen inside of hair follicle cells. But coming back to the main topic of this video, what impact, if any, does a big head or a certain skull shape have on hair loss? So according to this research paper, it says that skull expansion of the frontal and parietal bones, which by the way are these bones over here, the frontal bone and the parietal bone, will progressively stretch and pull tight the scalp tissue that overlies it. A constriction of blood vessels within the capillary network that serves the male pattern baldness region will subsequently develop. The resultant decrease in blood flow that follows will then reduce the supply of nutrients required by hair follicles to grow. So the idea put forward here is that growth and expansion of the skull bones then applies more pressure on the surrounding tissue that in turn puts more pressure on the underlying vasculature, that's all the blood vessels carrying all the blood, oxygen, nutrients, and so on to the hair follicle. And when these blood vessels are pinched and constricted, it basically starves the hair follicle and leads to hair thinning. And by the way, I'm not saying that this is true or accurate. I'm just saying this is the theory put forward by this paper. And that is that skull enlargement leads to tension, which leads to reduced blood flow, which leads to hair loss. So let's try and find out whether this is true or not by reverse engineering this process. So obviously we know that hair loss happens. There's really not that much to unpack there. So let's move on to the next step, which is reduced blood flow. So here we have a study that says in patients with early male pattern baldness, subcutaneous blood flow was 2.6 times lower than the values found in normal individuals, and this difference was statistically significant. We also have another paper here that says transcutaneous oxygenation was also significantly lower in the frontal scalp of male pattern baldness subjects than in either frontal or temporal scalp of controls. So we know that hair-bearing regions of the scalp have higher blood flow and oxygenation relative to balding regions of the scalp. And we know that balding hair follicles typically have a lower oxygen and blood supply. But then the question becomes, is reduced blood flow a cause of hair loss, or is it a consequence of hair loss? So let's have a look at that now. So there is definitely some evidence to suggest that reduced blood flow is actually a consequence of hair loss. If we look at the hair cycle, we start with the anagen phase, which is the growth phase of the hair cycle. This is where the hair shaft is growing, and the dermal papilla, which is a tear-shaped pod, which is highly vascular, is attached to the hair follicle, and this is what supplies the hair follicle with all of its vascular requirements. In the catagen phase, the hair stops growing, and the dermal papilla starts to detach itself from the hair follicle. In the telogen phase, the dermal papilla is completely detached from the hair follicle. The hair then sheds, and we come back to the anagen phase, where in balding scalps, the subsequent anagen phases will produce thinner and wispier hair strands. But if we focus on the catagen phase, we can see from this study that degeneration of the blood vessels in the dermal papilla during catagen is a secondary effect and not the primary cause for cessation of hair growth. So we know that in the catagen phase, the hair follicle gets a signal to stop growing first, and then the dermal papilla starts to detach from the hair follicle. And when we come back to the anagen phase, in a balding scalp, the miniaturized hair requires less vascular support, so the blood vessels supporting these follicles naturally degrade away. And we also know that when the superficial temporal artery is ligated, or basically tied off, there's actually no evidence that this then leads to hair loss. And we also know that scar tissue predictably develops alongside the progression of pattern baldness. And here we have a study that says that collagen synthesis by fibroblasts is significantly compromised when tissue oxygenation is less than a certain threshold. And so we know that signaling proteins like transforming growth factor beta 1 lead to the laydown of fibrotic tissue, and mature fibrotic tissue or scar tissue is largely avascular. So there is definitely some strong evidence to support the idea that a reduction in blood flow is actually a consequence of hair loss. But there is some conflicting evidence. So why might blood flow be a cause of hair loss? So here we have another study that says baldness occurred in persons in whom calcification of the skull bones apparently had not only firmly knitted the cranial sutures, but also closely narrowed various small foramens through which blood vessels pass. So in the skull, we have these holes called foramens or foramina, and when these become calcified, they basically get closed off, which can potentially reduce blood flow to tissues indirectly supporting the hair follicles. And we have other research papers that say arterial calcification was the answer for this and was found to be another contributing factor in hair loss along with fibrosis. And the diagram they include in this study says that scalp DHT goes up, androgen receptors goes up, fibrosis and calcification goes up, which leads to a reduction in blood flow, a reduction in oxygen supply, which then leads to hair loss. So if we go back to this theory, we can see that reduced blood flow is a consequence of hair loss, but it can also be a contributing factor to hair loss. So let's now look at scalp tension. So here we have a pretty well-known study in the hair loss space. And this is a study conducted by Dr. Brian Frund, who took 40 patients and injected 150 units of Botox into the scalp perimeter muscles. Now, Botox is a neuromodifier that basically stops muscles from contracting. It basically relaxes muscles, thereby relaxing the top part of the scalp, or the gallia aponeurotica, which is a layer of dense fibrous tissue underlying balding prone regions of the scalp. And here we can see a before and after picture of one of the patients after 2 rounds of Botox injections 24 weeks apart. And this produced a 75% response rate. So this is not a magical pill that works on absolutely everyone, but it does give some indication that tension, scalp tension, is at least in some way related to hair loss. And the study says Botox loosens the scalp, reducing pressure on the perforating vasculature, thereby increasing blood flow and oxygen concentration. And this is not a fluke. We've had a bunch of other studies like this one that basically produce the same or very similar results. So this was conducted on 10 patients with androgenic alopecia, which granted is not the biggest sample size, but nonetheless, we can see some pretty significant before and after pictures in this 24-week trial with 1 round of Botox injections. And once again, not everyone saw the best results, but enough people did that makes this an avenue worth exploring. And staying with the topic of tension for a minute here, we also have this study from back in the 90s, I think it was, where we have this scalp tension relaxer device that is put on the head as such, and it has a handheld pump which can then inflate this inner tube, which basically pushes the scalp upwards and in turn relaxing the scalp. And here we can see another before and after picture with a 65% response rate in the study. And lastly, here we have a finite element analysis study on the scalp. Finite element analysis is a computational method used to assess the tensile stress distribution across a plane. And in this study, they basically took a 2D model of the Gallia aponeurotica and measured the stress distribution. And what they found was that the tensile stress distribution actually highly correlates with the Norwood pattern, or with the progression that we typically see in pattern baldness, with areas that bald first exhibiting the highest tension and areas that bald last exhibiting the lowest tension. Now granted, this study is not perfect. This was conducted on a 2D model of the Gallia aponeurotica, whereas in reality we have 3-dimensional heads. So this is not a perfect study. That being said, it does give some indication that tension is in some way related to pattern baldness. And the study clearly identifies mechanical stress as an active factor in androgenic alopecia. So if we go back to this theory put forward by the paper we were looking at the start of this video, we've now covered blood flow, we've now covered tension, so we now want to see whether skull enlargement is actually responsible for increasing scalp tension. Is this true? Is this not true? Let's find out. So coming back to this study that we looked at the beginning of the video, the problem with this study is that it has no head measurements, right? So it doesn't provide any dimensions of any bald scalps or any hair-bearing scalps. And so there's just no data. It's just a hypothesis. It's just an idea. And then here we have another study that says the hypothesis argues that androgenic alopecia or pattern baldness is the result of chronic scalp tension mediated by pubertal and or post-pubertal skull bone growth and or the overdevelopment and chronic contraction of muscles connected to the Gallia aponeurotica. So when it comes to the contraction of muscles connected to the Gallia aponeurotica, we actually have evidence for this from the Botox studies. But when it comes to skull bone growth, once again, there are no head measurements. There's no evidence to support this. And here we have yet another study that claims that depending on the shape of the back of the head, this is going to impact hair loss in one way or another. And once again, this is a great theory, but there's no head measurements. There is literally zero data to substantiate this. And it leaves many open questions. Why is it the patients with acromegaly, which is a condition that leads to increased skull thickness, a prominent forehead, a prominent brow ridge, and a thicker skull, why do these patients not experience any higher rates of hair loss compared to people without this condition? And why is it the growth of the frontal bone and parietal bones can lead to hair loss, but not growth of the occipital bone? And so there's just so many flaws with the idea that the big head or skull expansion is the primary mechanism for androgenic alopecia. So at this point in time, there is no solid data to suggest that a big head leads to hair loss. It's great in theory, but we have no head measurements to substantiate this claim. So if we had the head dimensions of thousands of bald adults and the head dimensions of thousands of adults with full heads of hair, then we'd be able to plot that on a graph and see whether there's a trend or not. But at the moment, there is just no evidence to suggest this, so it's not something I would worry about. That being said, I do think it's important to keep an open mind. And just because we know that hormones are responsible for hair thinning, it doesn't mean that other things aren't also involved in the hair loss puzzle, right? We know that genetics matter. We know that androgen sensitivity, scar tissue, calcification, stress, dermal sheath thickening, there's just so many factors and so much nuance to account for that I do think it's important to keep an open mind. It's just that unfortunately, there's no evidence to suggest at this point in time that a big head is the primary factor causing hair loss. And lastly, if you're experiencing hair loss or if you know someone who's experiencing hair loss, be sure to download this free ebook. It's completely free and you can find it in the link in the description below.